2017, the Tanis Award, Best Plotting Mistake, Tanis, for display of data points. Today is Monday, 9 February 2026, and here I, Tanis Shearhurst of Seattle, reveal my 2017, the Tanis Award, my science communication picks for Best Plotting Mistake. Tanis, for display of data points, article type, peer-reviewed journal publication. So this award is going to myself. Yes, with the Tanis Awards, I can actually do that. This is a fitting one because of the value of it and it being my own. I actually was allowed to be like, this was actually a good thing, which is not, I've always loved school, and I've made an deliberate intent to learn while in school and perform well as like a way of assessing whether I'm learning or not. And so this one was an interesting mistake to make because I was like, I learned more by making the mistake than if I hadn't made the mistake. So it was kind of I pivoted myself. I self-pivoted. So the award is for, I was a publication that I was first author, two authors, I was first author, and published in February 2017. I've talked about this article previously in the peer-reviewed journal High Energy Density Physics, and it was carbon and oxygen under high temperature and pressure, so condensed matter physics. And in one of the plots, and I noticed it after it was like submitted for publication and then like came out, and I was like, you know, and I even got it to review, and there was one thing where I was like, and I was like, okay, and it went through review and stuff, and then it got published, and I was like, I went back to it, and so there was experimental data that I plotted on one of the graphs. I'm not going to show this in the spirit of the prize of the award. So this is about science communication. I should be able to describe the mistake without actually showing it. Or I'm trying to, right? I'm working on my self-improvement in science communication. And so there's a graph, a plot, and I had my results, but I also plotted experimental data from experiments in physics. And so people could compare, like, and assess and evaluate my results in the context of what came before me. And one of their data points got plotted, the proximity to my data points and lines and stuff. I was like, that's not right. And if I interpret it like that, what is it? If it's plotted in the correct place, it shows there's a first order phase transition, liquid phase transition in this material. And where the data point is plotted, people might be like, ooh, it's closer to like my data, and be like, ooh, like it's right. And it's like, for a first order liquid phase transition, the proximity of the data points to each other don't necessarily matter so much as the slope between the data points. So the slope of the line, you know, rise over run, right, for like super basic mathematics. That matters more than the proximity of the data point to my data. And so it's like, if I had plotted it correctly, it would have actually been the mistake I made actually worked against me if somebody just takes the plot and interprets it that way. And I was like, so far, like, I made the right mistake. Like, essentially, if it were moved to the correct place, it would be a lot more obvious. Okay, or at least from my perspective. So it's kind of like like it's a distractor as it got, and I was like, so if it were in its right place, it'd be like just kind of like smooth reading. Okay, yeah, we got it. Versus like now, it's like, ooh, look at the distracted. It's close to the line. That means it's right. No, that's the wrong interpretation. Or that's not how to evaluate that plot for a first order liquid phase transition. And so I'm like, dang it, people, you know, like it's non-technical, but maybe the non-technicals will get it right. Like the people who don't have any education because they like find the mistake and they're like, wait, that's not the one from that paper. But it was just like, it got plotted in the wrong place. And I was like, how good it is that I'm having this realization and going back and looking at my stuff. And like, it's really cemented in there. Like, there's no, I published this paper once upon a time and, oh, I need to go back and review it. I'm like, no, it's stuck in my tiny little brain because I chose pale yellow for, I think it was the oxygen atoms, and green for the carbon atoms, when everybody else in the universe chooses yellow and blue because of the colorblind. And I was like, I'm not patsying to a very teeny tiny segment of the visual spectrum spectator audience of human beings, right? So I remember because of that, and I remember it because of this plotting mistake. And there were other stuff. I like remembered the paper, the article very pristinely, in part because of this plotting mistake, and I learned a lot from it. And I was like, I learned to describe it in a very clear manner because I made a mistake that I'm like, but it's done it, like but it's wrong. It's like but it's not wrong. It's like, don't just interpret it at face value because that's not what a device order transition is graphically, you know. So I got really dedicated to my work, and so I was like, it's the best possible mistake I could have made, and I would not have ever thought to make that mistake, and much less that the learning that's come with it would come with it. So there we go. It's the 2017 the Tanis Award, Best Plotting Mistake, Tanis for Display of Data Points. This Tanis.